see many of my friends' face. I cannot see many of my friends' face, but I'm pretty sure we'll meet somewhere else. So my talk today is on the financial statement fraud detection, and the main data is for news, the analysis of news coverage. So this is based on my collaborator Qingfu Liu and Bo Wang and Kaixin Zhang. They are all from Shanghai. So the data is mainly getting from Chinese data. So I'll give you the introduction. And then the first one, of course, is very difficult in how to measure for financial statement fraud behaviors. And that would be my Y variables. And then the next one is to measure risk factors and the peer effects. And then after that, we need to will develop learning algorithms, adaptive learning, and aggregation of prediction. And all those three components from measure of Y variables to measure of X variables, which we take into account of peer effects, and to the algorithm for detection we call meta. Meta is a meta learning algorithm. And then I'll talk about performance and economic value. And finally, I'll conclude. So introduction, financial statements for are common in history. Infamous example include Enron's WorldCom Global Crossing at the dot-com era. So they certainly damage to investors' interest and the credit cornerstone of capital markets. They lead to inferior companies, dry out high quality companies. So detection financial statements frauds is essential for preventing fraudulent behaviors, protecting the interests of investors, and maintaining the stable and orderly operations of capital markets. So our methods is quite common. First, and it's challenging, measure detecting objectives. That is, how do you define Y variables? Second is collecting influencing factors. That's basically X variables, and then constructing detecting models. So these are the three components. And what are the existing literature? So the existing literature usually has limited sample. So usually they are based on financial statement for events that has already occurred. So in practice, financial fraud is really not really a simple question or a yes and no. Based on what's already occurred, it certainly create bias. Only those being found and being punished that being included in the sample, and also it's pretty hard to find the matching sample too. And then the second one is inference factors. So most existing literature only use the firm's own characteristics, but we know that financial behavior there are no, I mean, there are peer effects in financial statement force and the culture. So for this reason, we'll introduce the peer effect, and then detecting models. So far, most of literature only using one statistical machine learning algorithms, and financial fraud certainly are complex and dynamic, and we really need more robust meta learning. So here is our methodological contribution. So first, how do we measure financial statements fraud? We base on a generalization of term frequency and inverse document frequency weighted number of news. So we'll call financial statement fraud propensity. And this avoid the bias sampling based only on the event that has already occurred, like disclosed or confirmed fraud cases. And then in terms of feature set, we use peer effect, which based on the text similarity, the business similarity based on text, and then plus the learning algorithm to classify the peer. And this outperform the usual methods, like based on industry or region classification of the peer. In addition, we also introduce quarterly data that actually help us improve the detection. And then in terms of detecting algorithm, we use 18, actually, as we speak, we increase two more classifiers that are integrated into two meta learning algorithms. One called stack generalization, and the other is called semi-supervised adaptive learning. And this results in a better, robust and better performance of model for fraud detection. So this is in terms of methodological contribution. Now, in terms of result, this is an overview of methods. So based on 39 basic risk factors. So among those, 15 are financial factors, 13 are governance factors, 8 are market factor, and 3 are sentiment factors. So based on these basic factors, and then the time trend compared with the last time period, and then compare with the peer and the quarter data, we create 605 X variables. And in addition, we also have financial statement fraud, and this is news-based financial statement fraud propensities. And these feed back into, I mean, both X and Y variable feedback into those 18 classifiers. And then based on those meta learning aggregation algorithms, we get the output result. So this is it's the essential idea, and then we'll see how the result perform for those non-fraud or low fraud and high fraud, samples. So in terms of empirical findings, so we basically say financial statement fraud propensity is more consistent with financial fraud behavior. So it's more timely reflect the event, and also is more negatively correlated with the regulatory environment. So when the regulation is more intensified, the financial statement propensity score tend to be lower. So this more than other measures. And then the peer that we define based on business similarity and the clustering algorithm is better than grouping in terms of industry or region as classification, thinking that the peer is the culture of the regional or cultural industry. So we using business similarity is a better description. And then certainly using quarterly data, we showed that it improved the fraud detection too. And then also the algorithm that we use meta learning improve the detection results too. And we showed that each components in our algorithm, we call peer meta, helps improving detection results. So then of course, the most critical one, peer meta performs very well and has a great economic value in terms of tens of billions, as you'll see at the end of the empirical studies. Okay, so now let me begin with measuring financial statement fraud behaviors. So as I said, the existing literature using either event happened punished by the authorities, right, or non-standard auditing options by auditing firms, or the restatements. And these are only described the event that already disclosed or made public. And so our method is the following. So is based on financial news fraud propensity index, which based on the media reports. So the data that we're getting is from the database, China Economic News database, which basically collecting most of major news and chat into their database. And then we begin with the seed words financial fraud to search for the news. And this, of course, in Chinese, we using these four letters, 财务造假, and this yields 2,400 articles. Now, these are the preliminary articles that we are using. So, of course, we have to use software in Chinese popular called Jieba to get a bag of words representation for each of these articles. And then we remove the stop words from Baidu. So at the end of the day, each document is represented by a bag of words without stop words. Now we use a vector to word to vector embedding to identify 100 words that most correlated or most similar to financial, or most similar to fraud. And so this gives us really 100 by 100 words, right? And not all of those 10 words are useful. So therefore, we using manual review plus some kind of simple machine learning algorithms to choose some of the seed words. And here are really the term set that we use in searching for the news. So these are all the Chinese that we key in. So basically, I know many of you don't study Chinese. That's okay. The first one basically say financial, and then the second one of course is fraud, and this is fraud, right? So it could be also someone say financial fraudulence, right? Someone maybe say financial suspicion, and so on, right? So long as these two words appeared in the same paragraph, we retrieve such an article. So at the end of the day, with all those basic term words and searching over the database from 2000 to 2022, I think we get 424, I mean, thousands relate to financial news articles or reports. And then based on these reports, now I can see for each individual firm at the time T, what is the risk of financial fraud, financial statements for fraudulent propensity. So the way we calculate is the aggregated, I mean, term frequencies. So these term frequencies is these terms, right? So these two together. So how often this appears, and then weighted by so this is the financial propensity score. So for Jay's article, right? So this is the total number of the term being referred relate to financial fraudulence referred in that article, and then normalized by how many firms it has been I mean it has been talking in this particular article J, and then of course I mean there's a non-stationarity over time, so we also normalize by number of firms that reported in that at the time T, because there are more firms starting from early 2000, there may be about 2,000 firms to the end of study, maybe they have 5,000 firms. So we multiply a number of firms. So this is the definition, the calculation of financial statements fraudulence. As I said, is really the normalized, the suitably normalized. I mean, the financial statement fraud reports about that article, and we using the total term frequency as a intensity of propensity scores. And if I using this matrix, we could plot each individual firms over this time series, over this time periods. So the time unit here is year, T here is year. So we for each company, I can compute financial statement fraudulent, I mean propensity, and you can see a few quite infamous. I mean, financial statement fraudulence being actually detected. So now in terms of distribution, this is over quite a few thousands of firms. So in terms of distribution of this, so I summarize over the time. So of course, as you would expect, 5 percentile will be zero. Indeed, the median, I mean, financial statement fraud will be zero, and then this is the mean, and this is 95 percentile. So as you can see, so the peak is always at the time when there are some events, right? So this is the time Chinese join WTO. So firm maybe feel more competitive, business doesn't do as well. So there's more propensity score here of financial statement fraud. And this is the financial crisis, the next peak here. And this is the peak of trade frictions, trade war between China and US. So you can see all those relate to the events that we actually seen. So this is how we define the Y variable financial statement for propensity score. And now how does this measure to the existing ones, right? So for those company being punished So the actual committed financial statement fraud, the percentile propensity score is pretty high. So it's in a very high range. For non-standard auditing companies, that those events that has already happened, the propensity score also very high. And for restatements, right? So all those, as you can see, different severe degree, they have different percentile financial statement fraud. Now, the first one you may ask is, does financial statement fraud has a predicting power of those dummy variables that is penalized by authorities or asking to be restatements or subject to non-standard auditing and so on. So if we look at this, right, so our financial statement fraud based on panel regression, they actually all show that statistically significant have predicting power on those existing three dummy variables. And indeed, the predicting power is about 3 years ahead, right? So even 3 years ago's variables still have predicting power on this. And this is computed after adjusting for industry effect, yearly fixed effect, and based on a lot of observations. But on the other hand, if you say, does penalty this variable has a predicting power on financial statement fraudulent propensity, so the reverse is not true. And then the next one we may asking ourselves, does financial statement measure the fraud behavior? And the and this is the intuition. If financial statement propensity score measure the fraud behavior, so when the regulatory environment is more restrict, then the propensity score should be lower, right? And now how do I measure the regulatory strictness? We use the reciprocal 1 over the number of IPOs. So if the number of IPO is lower, means the regulatory environment is stronger. And another measure is using number of letters issued by the authorities, right? And then we run the regression. So the Y variable is our propensity score. And then for curiosity, we also using the indicator whether a company being penalized by authority or not, using the other three dummy variables here too. So this is basically the firm's effect, right? So this is the time effect. And then this is the regulatory environments, and there are the control variable that we use here. The control variable could be a firm size, leverage, return on assets, book to market ratio, stay-owned or not stay-owned company, and the regulatory here is what we want to see, the inverse of this and that, right? So if our measure is measure for financial statement fraud behavior, then under more restricted environment, this guy should be lower. So therefore, this one should be the coefficient beta here should be negative. So let's take a look at what the result. So the idea is to examine the impact of regulatory strictness after adjusting confounders. And we really showed that financial statement for measure the behavior. And here is
Hi, Jianqing.
uh-huh.
There is a question.
Okay.
The question is, how do you treat from the crowd? How do you treat the irregular time points of the news for individual firms?
Oh, we just do everything in 1 year. So at the time T here, we are thinking every event occur in the year using that we using year as a measurements. So there's no time irregularity here. So it's just
Okay.
yeah, is the individual company at the year T. Yeah.
Okay. So yeah, this is a question by Maria Grit that
Okay.
I just
Yeah.
yeah.
Thanks. Thanks for the question. Yeah.
Okay.
Yeah. And here we show that the right? So if I using the restricted as inverse IPO, reciprocal IPO, so our coefficient is negative, and that's what we would expect it. On the other hand, if you use the, let's say, number of log number penalty as your Y variable, or restate, or I mean non-standard auditing, actually the coefficients is either insignificant or just the opposite of the sign. And similarly, if I do number of letters as a measure of regulatory strictness. Again, our coefficient here is negative, but if you're using other measures, so they are the wrong sign or statistically insignificant. So these two really show the statement we want to make here: financial statement fraudulent propensity, financial statement fraud behavior. Okay, so now the next one is to define the peer effect and the covariates. So people it's very well known that fraud behavior are affected by peer culture and peer pressure, and the popular measure of people using say, hey, let's define peer by using industry or sector based on some standard classification standard. So the drawback of this is there are multiple standards. Sometimes I don't know which one to use, and there are multi-layers. I don't know which layer to go. And also it cannot fully reflect the timely operations. Now at the age of AI and the large language models, right? So you can easily, based on, let's say, use business similarity in the annual report to define the peer. Right? So we basically based on the business similarity and then apply a clustering algorithm. So you get a peer. And this, of course, the mirror is more comprehensive description of the business and also reflect dynamic change in business in year over year and better reflecting the contagion of financial frauds. So in our particular implementation, after we extracting a business summary, we use Word to documents to represent the business summary after filtering the stop words UJ-bar, and we define the cosine similarity, just like the angle between those 300 dimensional vectors. So we can define the business similarity after you do document to vector embedding each document being represented by 300 dimensional numbers, and then you can calculate similarity between these two. And we measure the effectiveness of the grouping methods. So basically is within group averaging similarity over time T, which is very concretely defined here. It's really just an averaging between group averaging divided by total average. And using this as a definition, our measures is certainly have higher score in terms of within group similarity than industry based either based on primary number or the secondary classification. And here is a few more details year over year, the grouping quality comparisons. So this is our algorithm based on the business similarity and the classification algorithms, and this has averaged much higher than the remaining other standard, classification used in China. And either you are talking about average or minimum or maximum is always much bigger than others. So this is just showing that we have better group similarities. And now if I just see how does business similarity evolve, and this is what you can see we do like year number of firms in our normalization. At beginning, not that many number of firms, maybe about 1,000, a little bit over 1,000 firms. So this business, as we go on more and more, there are more and more firms. So business similarity getting dense and dense. So here we just putting a graph if similar bigger than 0.5. And then we also run the regression, just trying to see if business similarity, if there's a peer pressure, that is the financial statement propensity score within a group. Does it have a prediction power on the individuals? And again, we showed this just like based on our similarity weighted metrics. So they are all statistically significant. Just show this once more again. And then the next thing that I know time running quickly. So the next thing we define is the risk factors, right, within and the peer effects. So in this case, we use popular and well-defined 39 factors. Among those, 15 are financial factors, 13 are governance factors. Eight are market factors and three are sentiment factors. So they're known to have good explanatory power of financial statement fraud in China, and this has been known. Now, how do we, based on this, how do we expand the basis? So we totally create 605. So this is the basic factor. So let me call F1 up to F39. This is 39 factors. Now, each of those has a peer, so I can calculate a peer average. So so this is like representing the peers average. And now I calculate how each individual firm different from the peer. So are you from the peer average? So that basically showing you are above or below the peer average in terms of financial, in terms of those factors. So this give me another 39. I can compare my own company with the last year's at this time of this all those factors. So this give me another 39. Now, if I apply this to quarterly type of data, I will get in 4 times as big, and this give me total 605 factors. And now I have Y variable, I have X variables. So the next thing is to aggregate those together. And this is the adaptive learning and aggregation of prediction algorithms. So currently we use 18. We are still revising the paper. I think the resulting paper maybe have 20. So these are like linear discriminant, quadratic discriminant, logistic regression, probit regression, naive Bayes, tree-based methods, right? Feed-forward neural network, supported vector machines, and so on. So this is so these 18 popular algorithms being used, and those 18 algorithms being put into a mega learning result. So one is called stack generalization, which basically aggregates output of classifiers. Each classifier will give you outputs, and thinking outputs as inputs, right? Thinking output as input. So you really aggregate 18 classifier result to get the results. And then adaptive learning is really feedback during the learning process. You feedback the mistake in testing a little bit back to learning, and this will allow you to improve the results. So
Jianqing,
here,
there is a question, sorry, regarding the previous table. So, so in the predictive regression, using Cliff one out means that the firm itself is not included in the mean calculation.
So can you say that again? In the calculation, the difference is,
Yes,
yeah,
yes.
yeah. I think in the calculation of this, yeah, we probably didn't exclude the firm itself, because I think each group have pretty big, let's say 30. So it's literally just like a similar to uh like a demean the residual, right? So let's say, yeah, I belong to group one, I can calculate group average and how much I'm away from the group average. So I don't think we deliberately exclude the company itself.
Okay, thank you. Thank
Thank
you.
you. Okay, so this is the learning algorithm. So first, I think we set data into training and testing as usual, right? And then based on training sample, you get in the outcomes, because I have K classifiers, so therefore I get K outcomes. Right? So these are K outcomes. So typically we just take in, let's say, majority vote. So that's a simple way of aggregation. But rather than doing majority vote, the stacker generalization is using these K outcomes as a new feature, and then I run the algorithm again, just like repeat the step one again. Now I just with the change X, and then I get a new classification result, classification results. And then among all those classification results, now we apply to the test, this new one already aggregated, apply to the test data, and the top 10 most consensus predictions most are feed back to the training. So and this step is adaptive learning is in the when I apply to testing data. So I took the testing results, 10 of those most consensus testing results being used, and their aggregated label and the result being feedback to the training. So it's back to the training, and then we repeat this this step many times. So actually 10 times, because every time you feedback 10%. So many times, so you get the result. So now let's see what is the performance and the economic value. So this is the empirical aspect. Again, we have arranged data in firm year from 2000 to 2002. And whenever I do the data, I use 5 years rolling data, so which is rolling data windows. And then so I have, as I say, I have 605 features. And then the detection result we will apply to non-financial frauds, like which have financial propensity score equal to 0, which is a little bit over 50% of the data. And then we apply to low financial fraud, which basically then further divide into half, that the propensity score less than median and non-zero financial propensity scores. And then the other is high financial statement for samples. This is another 25%. And then the evaluation metric, as usual, would be precision, recall, and the area under the curve. So here is the detection results. Again, this is year by year. So when we apply those firms, so if you're looking at the precision, so precision actually is very high. So precision is, so I'll give you a better example in the next one, is basically how many you call fraud divided by the total number you call fraud. And then the recall slightly lower. So how many fraud divided by total number of firms actually committed fraud. So this is lower, and then but it has very high recall for high risk companies, right? So this average is 81, and this is the area under the curve, which is pretty decent, right? Much bigger than 50%. So this is the area under curve for our methods. So now let's look at the outcome, right? The number of true and the false predictions. So again, because we use 5 years period. So our first learning sample is 2006, right? So this is the outcome. So this is the number of firms in 2006. Among those, 22 was true fraud. I mean, these really commit financial fraud, being penalized by authorities. True fraud is being penalized by the authorities, right? And then, of course, there are 22 false frauds, meaning that among 44 being called fraud, half of those I made a mistake, half of those are correct. And then this is non-fraud. There's one firm that actually committed fraud, been missed, right? So this is a missed discovery, and this is the true non-fraud. So this is year over year. So total over these 20 maybe 17 years. Among those 17 years, so totally we discovered this many frauds, right? And the recall is this, right? So this is the total number of discovery the true frauds divided by total number of frauds, right? This is true frauds, right? And this is the true frauds. So this is called recall, pretty high. right? And we'll argue recall is more important than the precision. And then of course the precision sacrifice, right? So among this recall, among these two discoveries, how many we call, totally is this plus this, right? We call these two together is the total number of fraud that we said, right? Among this is only this many is true. So this is called precision. Precision is the numerator are the same, depend on the denominator. Precision is divided by total number of fraud that you claimed, right? And then the recall is divided by total number of firms that actually commit the fraud. So, so we have pretty high recall and pretty high precision also for the non-fraud companies. Okay, so now you may asking, well, how important each component contributes. So if in terms of overall accuracy, as you can see, each components actually contribute to it. Blue means, the value. Blue means is contributes. So the accuracy. The accuracy increases. When I remove one components, then the accuracy will suffer. Now, if you look at the quarterly factor, right? So if you look at the quarterly factor, it's also basically saying the quarterly factor is important. If you look at our adaptive learning, basically saying adaptive learning is also important to each of those recall measurements. So in other words, most column are blue, which basically saying that the peer factor that we introduce, quarterly factors. So they are all very important. So this is the peer factors. As you can see, it's blue across all the items. So here, blue and red means if you remove one item, your accuracy sacrifice, you got the blue. If you remove one item, your accuracy did not sacrifice, you got the red. Okay, so now here is our evaluation of economic value of detection framework. So what do we how do we measure the economic value? So we basically using financial damage as the measure. So basically it's the decline in market capitalization from our detection, which we detect much earlier, to the actual announcements, right? So, to the financial fraud announcements. So this is the actual definition of detection value is the market value decline during this time period when we detect it to the event being announced, and this is among the true discoveries, right? Among the true false. And then, of course, we also have missed discoveries, right? So this is the market capitalization decline. So in this case, the missed discovery, we subtracted market capitalization, and then there's an auditing fees. So this is the auditing fee that we actually we auditing these firms, right, through discovery, and then plus false discoveries auditing fee. We also adding those together. And so this is the market value. And we claim that the recall is far more important than precision because the potential the financial loss is much bigger than auditing fee. So and to illustrate this, we basically set up a scenario where you have 100% precision. So in other words, when you say a firm is fraud, it's really fraud. A firm is not fraud, it's not fraud. But because your conservative decision, you also miss a few a few discoveries, right? So and we reduce recall to 90%. So if I reduce recall from currently what we have here is 98% to 90% and increase precision to 100%, you'll see what is the economic value difference. So this is let's say look at the first year. So the detective value is this 2 billions, a little bit over 2 billion, and auditing cost is 65 million. And then we also have missed discovery of one firm, which it costs 112 million. And the net value is this one subtract by this one and subtract by this one. So this give me this, right? So if we change the scenario, to 100% precision, but only 90% recall, the net value change would be declined by 261 million. And we did that year by year. Of course, the later year, there's more firms, all those numbers are bigger. So if I add in those together, so the net value of the algorithm actually have 137 billion. And the net value, so if I change the scenario just to have more precision, a sacrifice of recall, so the net value of detection is 21 billions. And of course, the recall and the recall rates and accuracy, they're all depending on the threshold. Currently, we set 0 as threshold. If you take 20 percentile of financial statement propensity score, among non-zeros as a threshold, so then the recall would slightly decrease, and then of course your precision will increase. So this just showing you the sensitivity of recall, which is relatively stable, around 98%. Only when you get into very high high threshold, then it getting lower. So let me conclude. I know is 40 minutes. So the conclusion is financial statement fraud measured. Financial statement fraud measure constructed by media coverage can reflect financial statement fraud that has not yet been officially disclosed or confirmed. And this expanding considerably the research sample and the recall rate, because we were able to detect some of those has not already been detected by the authorities. And peer identified by tax similarity of business operation reflect better the market competition and therefore improve the quality of group division. And we adopt the relative financial statement risk frauds that help us improve the prediction of financial statement fraud models. And then the meta-learning algorithm help us also improve the prediction. And we show that the economic value of the framework is large, and the recall is more important in terms of economic value, because if I have so that I have less missed discoveries at expenses of more auditing fee. So the recall have a bigger economic value. And that's pretty much I want to say. We posted the paper last year in SSRN. So if you are interested in the paper, comment and suggestions are certainly very welcome. Thank you.
Thank you so much. Thank you so much. So there are 3 questions.
Mm-hmm.
I mean, the first question is by Etienne Wheeler. And question is general question. 605 variables is rather impressive number. Are you concerned about the curse of dimensionality when applying your learning algorithms? Have you considered some form of regularization or dimension reduction?
Yeah, that actually very good questions. So a lot. So I think some of those we didn't get into details. So we actually doing some, like when you do, let's say, neural network. So we're hoping the neural network itself has some kind of regularization itself. When we do, let's say, linear classification, they have some kind of curse of dimensionality there. The good thing is that when we do aggregated learning, probably not as important. Remember, I think our sample, I think it was in the order of, I think our sample is in the order of pretty big, like tens of thousands of samples. So there are, and indeed to also to address further the curse of dimensionality concerns. So I asking our students just a few days ago because of this talk to add in 2 more like a principal components regression type of thing we call form predict, and using these 2 selected variables, and then we'll see if the result can improve further. Yeah. So in other words, each individual doesn't play a very fundamental role there, because we are doing doing meta learning. But kernel dimensionality definitely need to be addressed. Yeah.
Thank you. So there's a second question is by Eric Sen, and his question is question to data used regarding data used. Over what time horizon were market cap declines measured? How about audit fee estimated?
Okay, very good question. So the market decline again is uh, our estimate, right? So when we detect when we got the news, we apply our model. We already claimed that company actually right. So the company will have fraud, has a high risk of fraud. And then we just and from that point, there's a market value on that date to the market value of the public announcement. So the difference of this is the market capitalization decline that we calculate here. And the average auditing fee is based on the actual auditing fee that we collected. I think it was published somewhere. So this is the audit. Each firm, let's say if I audit 100 firms, 100 firms average fee, I think it was published somewhere. We use that number and then just do a simple calculation of like how many firms being audited is the true positive that here we have to audit, and then false that we audit the false fraud that we a number we use here. So audit fee in ER is cutting from the publication that we collect and use this as an estimate.
And there's last question is by anonymous attendee, and this person is asking, this is excellent. Is there a real industry example of this, please?
Is there any
real industry example of this? Is someone using this, I think?
And in this, I think, well, I think it's very in application. I think this application is more regulatory or public good, right? So in other words, actually, it has a very important guidance, right? So if you really believe the detection model, and one firm being claimed, let's say, being detected to be financial fraud, yeah, so I mean, you can see that the market is, I mean, it is really overpriced, right? So you can really either short this company or avoid this company. I think there's a lot of really industry. I mean, a lot of, let's say, trading strategies can be made based on this. Right?
Yeah. Can I ask a question that might be the last if no one is asking a question? This is regarding the false frauds, the false positives. So is there a variable that you can like delete or add that you can decrease that false fraud number? Like the number is 867. Is there like a variable, a trick, like a delete a variable that will decrease that number? Is there a like way to improve the false fraud?
Right. So the false, that's a very good question, right? So the false fraud, yeah. So it's always like it's really the thresholding issues, right? So how do you define the fraud? So currently we classify in the sample, I mean, whether it's fraud or not, using a pretty low standard. So it's related to sensitivity study that's showing here. Basically saying, well, and if you get any propensity score bigger than 0, we regard as fraud. So if let's say here, let's say it's bigger than 20 percentile, I regard as fraud. Then false fraud would be reduced, and false fraud being reduced, but then at a cost that I'm less sensitive to detect some true frauds, right? And then we setting a very low standard because we were thinking for market value point of view, true fraud is more important in a sense because the potential market decline. In other words, committing a fraud, a company that committing a fraud maybe have 10 times or 100 times more costly than auditing fees. So for this reason, we're just setting a very low bar. But that you are right, you are absolutely right. I can increase the threshold and make it higher. Yeah, make it a better precision.
Thank you so much.
And I was hoping by adding 2 new two new members into this ensemble learning. Hopefully, there's more into like more modern ones, more into dimensional reduction that one of the people ask into the account. Hopefully, that maybe improve. By doing this, we can actually improve that the results. Yeah.
Thank you so much. So, are there any other questions from the crowd? No. So, thank you so much.
Oh, thank you. Thank you all. It's really great pleasure. And thank you for organizing this and give me an opportunity to communicate with so many of my friends, even though I do not get a chance to see them. But thank you for a great question. Anastasia, thank you too. Yeah. And
thank you very much.
Yeah.
Thank you. Thank you.
Thank you.
So, yes, I think